Welcome back to the Odyssey channel, where science is both good and flavorful.
Dear friends, in 1974, Stephen Hawking predicted that black holes emit blackbody radiation due to quantum effects near the event horizon. But until now, there has been no concrete evidence proving the existence of Hawking radiation.
Recently, however, scientists at the Israel Institute of Technology have created an artificial black hole for research.
Indeed, they have obtained the first evidence confirming Hawking's predictions are correct. Let's explore together in today.
Enjoy watching the video, and don't forget to subscribe to Odyssey and turn on notifications to always.
Now, let's dive in and explore. A black hole is a region of space-time with an extremely strong gravitational field. It is so strong that no matter can escape from it, not even light.
According to the predictions of general relativity, a sufficient amount of mass concentrated within a sufficiently small region
will warp space-time to form a black hole.
Surrounding the black hole is an area defined by mathematical equations, known as the event horizon.
In this region, any matter that crosses it cannot escape. Black.
Thus, it seems we cannot observe or detect black holes in the universe directly. We only know of their presence through gravitational interactions or when a black hole is absorbing matter from another celestial body.
In 1974, Stephen Hawking hypothesized that black holes in the universe are not as pitch black as we imagine, but instead emit a type of radiation called Hawking radiation. It is believed to be generated by quantum effects at the event horizon, and Stephen Hawking was the first to provide theoretical reasoning for its existence.
According to his theory, Hawking radiation reduces the mass and rotational energy of black holes, which is why it is also called black hole evaporation.
This led him to conclude that black holes cannot increase in mass by other means. They will gradually shrink and eventually vanish from space. For microscopic black holes, they are predicted to emit more radiation than larger ones, causing them to shrink and disappear faster. But until now, no astronomer has observed this mysterious radiation around a black hole. Many arguments suggest that this radiation might be very faint, so with current technology, we may never observe Hawking radiation in the universe. Therefore, to search for the radiation Hawking predicted, scientists worldwide have built special systems like the Fermi Space Telescope,
specifically designed to detect gamma rays from evaporated primordial black holes, or large particle accelerators to create many black holes for study.
In September 2010, a signal closely related to Hawking radiation from a black hole was announced, observed in an experiment involving optical light pulses. However, the results have not been verified and remain controversial. But recently, researchers from the Israel Institute of Technology have achieved it. They created a mini black hole in the lab to observe Hawking radiation. The scientists created a gas flow containing about 8,000 rubidium atoms. They were cooled to near absolute zero, close to 0 Kelvin, or nearly minus 273.15 degrees Celsius. The gas flow was held in place by a laser beam. At this point, the scientists created a mysterious state of matter called a Bose-Einstein condensate. In this state, thousands of atoms act in unison, as if they were a single atom. Next, the scientists used a second laser beam to strike the gas flow. This created a special region where the gas flowed inward like a waterfall. This area functioned like an event horizon. Half of the gas flow moved into this region faster than the speed of sound, while the other half moved slower. During the event, scientists tried to find phonon pairs, or quantum sound waves, naturally forming around the gas flow. After multiple observations, researchers noticed that in the slower flowing gas region, phonons moved opposite to the gas flow, tending to escape the event horizon area. Meanwhile, phonons in the faster flowing gas region seemed trapped by the super-fast gas flow. They appeared to try escaping but could not. After identifying these phonon pairs, researchers had to determine whether they were related to Hawking radiation and whether Hawking radiation remained constant over time, given that these phonon pairs were trapped and stationary.
This research and analysis process was extremely complex because every time scientists finished the mini black hole they created, it seemed to be destroyed immediately by the heat generated in the process. Thus, the research team had to repeat their experiment 97,000 times. They spent about 124 days of continuous measurement to find correlations.
Finally, their patience paid off. They proved that Hawking radiation is stationary, unchanging over time, which aligns with Stephen Hawking's original predictions. Subsequently, the research was published in the journal Nature Physics on January 4, 2021. This is considered the first evidence proving the existence of Hawking radiation around a black hole.
Of course, these are only mini black holes created in the lab.
Researchers believe that creating mini black holes in the lab poses no danger to us.
Because when many black holes are generated, they seem to vanish immediately after the heat generation process.
Therefore, you can rest assured that creating a black hole that grows and destroys the world only exists in science fiction movies. From this, we can see that reaching a conclusion in science
requires researchers to put in tremendous effort to achieve it.
In this study, with 97,000 experiments conducted throughout 124 consecutive days, we can see the perseverance and efforts of the researchers. Of course, these are only the initial pieces of evidence proving Stephen Hawking's prediction was correct. And we cannot yet say with 100% certainty that many artificial black holes operate and exist exactly like natural black holes.
On the other hand, because they only appear for a very short period of time,
so physicists will need more research to confirm the above. Only until today, after nearly 50 years, has humanity obtained the first evidence. Proof Stephen Hawking's prediction is correct.
It must be said that his intelligence is truly extraordinary.
When Stephen Hawking proposed the hypothesis in the mid-1970s,
he believes that cosmic black holes have a phenomenon of radiation leakage. This theory overturned the core principle of the universe that was believed at the time.
Since Albert Einstein published the theory of relativity in 1915,
predictions about the existence of black holes based on the theory of relativity all suggest that
a black hole will swallow everything around it, even light. Black holes are likened to bottomless abysses, where matter and energy can never escape. But Stephen Hawking hypothesized that black holes are not actually completely black, they emit radiation.
Later, that phenomenon was named Hawking radiation, precisely on the day of his death, March 14, 2018.
What a coincidence, this is also Albert Einstein's birthday. With this hypothesis, Hawking resolved the mistaken questions of physicists. When Einstein's theory, despite being widely applied, could not explain the motion of particles within the atom and the quantum world. Initially, Hawking's theory was highly controversial. But later it became the foundation connecting relativity and quantum mechanics.
He argued that black holes must emit radiation as they gradually lose mass and energy,
then gradually shrink, eventually evaporate and disappear into space. However, Hawking radiation poses a new question, the black hole information paradox. If a black hole disappears, all information about the matter and energy within it would also vanish. Meanwhile, physics asserts that information is never lost. And this remains one of the major contradictions between relativity and quantum mechanics. Hopefully in the near future, scientists will be able to solve these complex problems. So today, Tot2V and friends have explored the first evidence for the existence of Hawking radiation.
Wish you all enjoy watching the video.
Now, please choose the video on the left or right side of the screen
to join Tot2V in decoding other mysteries of the universe.
See you again in the next videos. Goodbye.
Please subscribe to the Key and Go channel so you don't miss any exciting videos.